Hi, everybody. I'm Adrian. I'm CTO, software developer for Filbo, and I'm going to take you through discussion about what Filbo is, the architecture, and how to build software sustainably and in the long term. So this is the main goal of this presentation. This is today's agenda. So we will do a short introduction here on the Filbo architecture and the Filbo product, just so that you get an idea of what Filbo is. The second part is the crux. It's the where I tell you about the building blocks that we use to build our backend. And the purpose of this part is just to show you and to tell you a little bit about what our architecture decisions were and the kinds of tools we use from the Azure cloud to achieve these basic building blocks when building software. So jobs, APIs, orchestrations, databases, and so on. So what we've chosen from the Azure cloud and what we are using and why. And the purpose is to go through these building blocks and just offer someone a complete toolkit of creating software from scratch using the Azure cloud and the .NET Core ecosystem. With getting the infrastructure and complexity that comes with infrastructure out of the way and focusing on building functionalities and features for the clients. And the third part is a bit philosophical. It's about some concepts, principles, lessons that we learned along the way that can make a long-term vision for a product and for a platform make more sense and have more coherence and even more success. So let's get started. So going into the first part. What's Filbo? Filbo is a product. It's a software product and a technology platform. Its purpose is to be a toolkit to solve problems that entrepreneurs, small businesses have, and to solve them in a modern digital way without a lot of hassle. And we started building this product almost 2 years ago. And the first use case that we built was a business loan. So Romanian entrepreneurs, small businesses can go to our website and apply for a business loan quickly, remotely in 10 minutes and get the money without ever having to move and to go to a bank. This is the first use case, but in this toolkit, in this suite that Filbo represents, we plan on adding flows for embedded finance, so enabling other platforms and products to use Filbo directly in their products, in their applications, so to use Filbo workflows like financing. And also in the future, we plan to build a e-wallet and a payments and cards infrastructure around that wallet to complete the financing parts of getting a business loan. So this is the Filbo product. It's launched in Romania. It's built by a Romanian team. And this is the introduction about the product. Now we're just going into a bit of detail on what the Filbo loan is, just to get an idea about the complexity and the process and how it happens in the background. And just a second. So it all starts with intent. The customer will go to our website, the company needs a loan. The administrator of that company will go to our website, apply for a loan, answer a few questions. And in the background, our systems already will start processing, gathering data, and just completing an image about this customer as good of image as we can complete with limited data that we have. And then we go into an analysis phase where we take all of this data, we take some more information from the user to complete our Know Your Customer information and some mandatory company documents. These get updated into the platform, Then a set of automatic checks and manual checks happen, and then we then get to the fun part where we actually send the money to the customer. We generate and sign a contract, and then we make a payment into their account. So this is the end-to-end process of getting a loan. In this summer, we achieved a time of 8 hours end-to-end for this flow. So we are very proud of that, because that is very fast for a business to get the money into their account so quickly. So yeah, this is what we take great pride in, and we work to improve all of the time. Now, in order to achieve this, we go to this image of an overview of our architecture and our systems, just to get an idea of how this happens. So we have a web application and we have a mobile application where users log in and perform the actions. And we have the embedded finance flows, which basically means that our APIs are integrated into other apps created by partners. So these are the user facing flows, right? And anything that happens in these user facing apps will eventually reach our API, our public APIs. And this is the interface to our platform. And below this, the public APIs, the API gateways, if you will go to the platform itself. And this is where we have all of these services that work together, integrate together, solve some specific business purposes. And this is what we call the Filbo platform. And below this, we have the backbone, the infrastructure, which is Azure Cloud. And I have on this slide now some the technologies that we use to create these services and applications. So the Filbo web is React. We love React. We think it's a very nice and powerful way to build web applications. The Filbo mobile app is native script, which allows us to code once in native script and build for Android and iOS the same app. And all of the backend part, so what's below this line here, it's built with .NET Core, C Sharp, mostly Microsoft technologies like Azure Pipelines, Azure DevOps, Git, and Azure Boards, and the Azure Cloud, out of which we use some resources predominantly like App Services, Azure Functions, and Azure SQL. And we'll talk about those in greater detail later. We also have a back office app that's also built in React. I told you we love React, which interacts with these services over here, the back office app, and will just provide the back office flows to our employees and workers. So just remember and feel free to write questions anytime, and I will check the chat from time to time and answer questions. So that's fine if you do it throughout the talk. We will have some places and some spaces and some breaks for questions, so don't worry about it too much. Okay. Moving on to the anatomy of a Filbo service. So when we talk about a single service, this is how it looks like. Maybe this image sums up really nice what this a single service looks like on our side. So we split these services based on domain-driven design. So we try to think which are the features and flows that belong together in a cohesive manner, and we group those inside the service. So we have a customer service, a risk service, a KYC service, and so on. So this is how we separate services. And what we think is a service is not an API. It's not a host. It's a suite of technology elements that solve specific business flows that belong together and should be solved together. So this is why when I say a service, it means that we might have multiple APIs hosted. We might have an Azure Functions host, and this part on the left here It's about hosts. So this is what runs in the cloud as either app services or Azure Functions hosts. And we can have two, three, four, or even more hosts for a single service running in the cloud, serving specific purposes. And we'll get to that later on why this is the case, and why we have three APIs for one single service. One important aspect here is the isolation between services. So what we consider a service is an entity that will have its own database. So there's no sharing databases between services. One service will have its database and will be the owner and have the responsibility to work with that database alone. No other service will write directly in another service's database. This is important note. And isolation goes even further on the code repositories, the build pipelines, release cycle. It's really important to be able to deploy one service independently of another service. This way they can evolve and grow independently and not in a monolithic or coupled fashion. Each service will have its own logs, alert, dedicated cloud resources, and even optionally we can have a different technology stack for a certain service if we decide that that is the case. So if there is a certain service that some part of the team wants to write in Python, that's totally acceptable and that's fine because we have this isolation. So the choice of a technology stack for service will not affect other services. So this concept of isolation is really important. We don't really use microservices to name this. We simply call them services, but this is the philosophy behind what a Filbo service is. And now, moving forward, this slide shows how services work together to solve certain problems. So when a call comes from the mobile app, let's say this happens, this will call the core of the service, the core domain. And this core will have interaction with the outside environment via this infrastructure layer here. So the right side of the service is the infrastructure layer. So it will go and generate an event, send it to event grid. Maybe the same flow will go and call via API another service. This is acceptable. Maybe this flow then will save something in the database, right? So this is how services will interact with each other and will store the data. So this is how we integrate all of this together. So same happens with any call that comes from the outside. And also outgoing calls from the platform will follow this same kind of approach. So a call comes from the Filbo web app will be handled by the application logic, and then maybe it will call this API from another service. This will also have application logic and will be responsible to process that API call. We'll have ownership on that API call. And then we'll call maybe an external provider to achieve this. And maybe it will save something to the database. This is how everything works together. Now, I'm done with this first part. I already see a question. What is the overall cost of running the entire system? Well, Alina, it's complicated. It depends. We run over 25 to 30 app services at the moment in the production environment, and this together with databases, with everything that's surrounding this, like app insights and storage accounts and so on, we get a really small cost every day. A really small cost, let's say it's under $50 per day to run this. But if we think that we also have some other workflows like the test environment, which also requires some resources. Of course, we're not pumping that environment up too much, but we also get some costs from there, and also some other workloads and jobs and storages that are not directly related to the platform, but they are needed and they also generate costs. But it's a very low cost and it's scalable. So this is what I'm going to talk a bit throughout the next part about the fact that these resources that we chose are scalable and we can easily, as Traffic grows, increase the scale also, and this is, I think, a more important part because this is power, the power to to launch something and not have to worry about building complex systems that cost a lot of money as infrastructure, as the backbone of what you're building. You can just eliminate those worries and just focus on delivering value to customers. Okay, since there's no other questions here, moving on to part two, the building blocks. The first building block is the API. It's the classic API that almost every service will need, and we have for one service many APIs, and this happens because each API has a specific purpose and some constraints around security, around how it works and how it evolves in time. So the public APIs are used by callers from the internet. So, for example, the mobile app will call our public API, but this is a publicly exposed API that the internet has access to call. This is why this has specific security concerns that need to be addressed here. The internal API is an API used by the applications to call each other, and this will have a simpler server-to-server authorization and authentication model, and it is hosted in another VNet and has some specific things of its own. And the back office API, the same. This is strictly created to cater for the back office app. And this API will have some specific authorization model. It's a simple model from integrated with Active Directory. And this is how we think about these things. So one service might have many API hosts, and that's fine. This is giving us flexibility, extensibility in the future, and it decouples some of these APIs from one another and allows us to make quicker changes. Now, each app service has its own App Insights instance. This is an important tool that we use. The App Insights is an important piece of the puzzle here because it handles logs. You can configure health checks and run them every 5 minutes, let's say. You can have a keep alive on the App Insights instance by calling a health check or some other endpoint. You can generate alerts when your service is not healthy anymore. You can generate an alert, and you can even configure some health probes in external services. So if your service is calling this external service here and you want to make sure that that endpoint works all the time, you can configure from App Insights a probe in minutes and then have it run every few minutes, and basically you're set. So App Insights is a great tool coming out of the box. You can just configure it for the app service and we move on. We have this as standard. So each app service gets its App Insights twin and then we move on. We found this to be really valuable. We host app services inside the Linux App Service plans. This is something that we do because it's cheaper. So we can go to an upper tier of quality. We go to premium V3 tier at the moment for much less money than going to a Windows app service plan. And because we run on .NET Core 3.1, this is compatible. It's fully compatible between Windows and Linux, our build, and we don't have to worry about this too much, but we do get some good cost savings because of this. Some plans are even a third of the cost when running in Linux compared to Windows. So it's a great hack to get better infrastructure for cheaper, for less money. An important note here is that you can scale these app services from basic to premium as your requirements grow. So you run an app service plan, you run inside this plan a number of app services, as many as you like basically, but what you need to be sure of is that you have enough RAM and enough CPU, and you will monitor these app services and app service plans to make sure that you have enough resources and then scale accordingly. You can even use auto scale, but we scale manually. What's important to note here is that you can start from basic and reach premium later, so you can start really cheap. to run this. It's out of the box. You don't need to think about it too much. Just start with basic and go from there. Again, on app services, a bit more information. Each service uses a storage account. So Azure Storage Account is a great tool that allows us to use an Azure Storage Table, one or many storage tables, which is a great tool. I will talk about it a bit later. It's a really interesting tool. It's a very scalable, simple table in the cloud that you can use for various purposes like logs. An Azure Storage Account allows you to have any number of Azure Storage queues, and this is what we use for queues. So these queues, we have them and we create them for each service, and depending on how many we use and for what their purpose is, they will just serve this basic role of being a queue and receiving queue messages, and we can have many queues for each service. So this solves the workload of having a queue somewhere. You don't need to go too far for this. So having a storage account for each service, it's simply a matter of going to the storage account, creating a queue, and then using it from your code. So out of the box, really simple to get set up, and it's out of the way. You can focus on the business value and creating solutions without having to think too much about the infrastructure. Azure App Service is a really versatile tool, and it's a Swiss Army knife. So give it a go. It has a built-in service managed certificate. So you simply click and you get a SSL certificate out of the box for free. You can bind your domain name. You can use SSL only option. You have backups and point-in-time restore out of the box. You simply need to click and configure these. So it's a pretty amazing tool because it gets a lot of things out of the way early when you start developing a platform like this. So this is why we encourage people to just go with Azure App Service. And regarding costs, this is scalable, as I was saying. And regarding the how much more this costs as opposed to creating a virtual machine, it's about 30% more. So the resource you get when you instantiate an app service plan is about comparable in price to the just going and getting a virtual machine. But you get for this 30% more, you get all of these features and all of this functionality, which enables you to start building and just focus on building features and just get out of the way these infrastructure concerns that you don't really want to think about too much when you start building features and when you want to ship things really fast in the market. Moving on, Azure Functions. So the Azure Functions is a workload that's really popular, and we use it for lots and lots of problem solving around our services. So we can have triggers from Event Grid that are just instantiating an Azure function. We can have queue message triggers. So just when any message reaches this queue, a trigger will be made in a function. This is really important flow that I will tell you a little trick about in a minute. We can have scheduled runs, so you can build a function and just configure it to run daily or hourly or once every 5 minutes. Really easy to do out of the box. And what's nice about it, it's also that it has resilience built in. In case of an error, it will keep retrying in a configurable way. So you get this little bit of resilience and robustness out of the box with this function trigger. Now, what's really important here is that it runs on the consumption plan and you get some free compute out of this. So you can run 1 million calls of these functions for free in Azure. And this is really nice because we found a little trick that helps us in the case of asynchronous execution when we have flows coming in our APIs that don't require a synchronous response. We simply throw them inside the queue and then return to the caller accepted message, and then asynchronously this function will get instantiated and will start executing, but this time it will be in the consumption plan. It will be for free. It will not run inside our APIs, which cost money because they're on the app service plan. So this is a nice little way to get some free compute when you're doing asynchronous stuff. So basically, the Azure Functions replaces the classics, job managers, background workers, and so on. You don't need these kinds of classics anymore. You can simply configure everything related to jobs and triggers uh, very easily, and you don't have to think about it too much. One extension of Azure Functions is this Azure Durable Functions. We use this tool to solve our Saga pattern and orchestrations workflows. So whenever we get this kind of complex, distributed, long-running flow that needs to be executed, we use Azure Durable Functions because this is a really simple way to do this. You write code as you normally would in C#, and the Azure Durable Functions simply interpret this code and run the code as distributed long-running code, but for you it looks like very basic C# code. This is a revolution in itself because you can write really simple code, but in the background, the durable functions will call other services. So let's say that you have a durable function here that has to wait for some other event to happen. It has to call a service. It will call some service. It will call some service here. It will uh, access some messages from the queue. It will wait until an event from event grid. So a single C# method will do all of these things, and the code will be really clean. But in the background, all of these things will be happening and will be triggered, and you can solve really complex flows with Azure Durable Functions with ease. This is a really productivity feature for us. So, and this is how we solve this matter of orchestrations. And we prefer using orchestrations as opposed to choreography because in orchestrations we feel that we can have a clear owner. So the owner of this orchestration is the service, this service here. So even if we have a distributed complex flow that is running, there is a single owner. It's the owner of the function, and that owner is responsible for the function to complete successfully and get its final and desired result. Moving on from this slide, going briefly into Azure SQL, there's no innovation here. This is a basic SQL service, but there's some efficiencies around this service. It's managed. It's a managed service, so you get scalable price. You start from 490 per database. You start from this and just go up until as your requirements grow. You can also use an elastic pool, assign some resources, and once you get close to those resources, you can increase your elastic pool. So you can assign the v core and the 2 gigs of RAM, and then when or some storage like 100 gigabytes, when that comes close to being consumed, you can just scale up more. So it's totally scalable system, which is really nice. It's out of the box, and it has these cool features like backups, point in time restore, multi-zone redundancy replication. These are just one click away. So if you have requirements like regulatory requirements, which we do because we do activate in the financial sector, and when it's about people's money, you know that you will have some regulations around that always, and we are not a stranger to regulations, and we do work in a regulated environment. So we will often have requirements like, okay, this data needs to be in 2 different geographies or zones, and you need to provide with high availability access to this data, or you need to have a disaster recovery plan that's properly made. This is where these kinds of infrastructure uh, configuration built-in tools, I would say, they're so useful because again, we use these, we configure these, we spend some time understanding these configurations, and then we simply move on. We don't have to build anything. We don't have to configure really complicated stuff. They're out of the box features that we use. So this is about the SQL. We don't think about this too much. Of course, there's also a great deal of talk and interest about NoSQL databases these days. We do consider them, but we found that the Azure SQL is it's a good tool, good enough tool to solve most of our problems elegantly. And we do like the ACID semantics of a relational database. So we don't want to give those up at the moment. And for the kind of workloads that we have, this is really a good tool and it's enough for us. Okay, question from Alex. How about the cost of Azure durable functions? Would it be cheaper to have one machine doing the job than those functions are doing? Alex, this question, it's really interesting. Up to 1 million calls. So Azure durable functions, they get taxed the same as Azure functions. So um, this means that the cost is related to how many calls you have to that function. But an Azure durable function, it's a process that will constantly invoke steps of the function. So when you do have a simple durable function like this that is started, actually the durable function runtime will call this many, many times. You will get many calls and re-enter. So it's a re-entrant function. Re-enter this function in time. So maybe once every few seconds, maybe once, maybe even more often. So this will be counted as a function call, and you only have 1 million free function calls. And this is an interesting topic. We haven't reached yet 1 million calls per month, so we don't worry about cost at the moment. But cost is not that high. So I was looking at the cost for function calls after you reach 1 million. It's totally manageable. It's not a high cost, and maybe having one machine doing the job, maybe it would be cheaper. I don't know, but we didn't really compare this exactly because you would have to understand um, you would have to set up that machine which would host the functions runtime. You can actually do that. So Microsoft allows you to not go with the consumption plan and just create a host, a VM, where you run the functions. So this is totally up to you if you want to do that. So Microsoft offers this out of the box, and this is why the question is, I think, not that important. For Azure, usually the cost of function scale is very steep. Again, I didn't get to this part yet, so we didn't hit this pain point yet. I hope we won't hit it too badly, but yeah, um, it solves the problem, allows us to think about the business functionality and the features and the user features, and that's great for now. Moving on, I told you I would spend some time on Azure storage accounts. Again, great tool out of the box, allows you to store documents, files in Azure Blob Storage, and this is obvious from the name. But what's not obvious is that you can have storage tables, as many as you like. This is a infinitely or massively scalable table. You can go to gigabytes. I think even more than that. You can go to a massive scale. From what I remember, it's table where you can simply add a lot of data. We store the logs here, and you can partition these tables. We partition them by hour. So one partition for us is the hours worth of logs. If we want to investigate what happened inside 1 hour, this is a cool tool to use in some specific use cases. But it's out of the box available in the Azure storage accounts. It costs nothing except the storage that you use. So whatever you store in it. The Azure Storage Queue, we use this to solve all of our messaging and commands type of workflow. So not for events, that's event grid, but for messaging and commands, this is what we use. So we enqueue messages, we Schedule messages, this is built in, so you can send a message to this to a queue and just announce or just configure the time when it becomes visible. If you want to delay, if you're generating an email notification for a customer at 3 o'clock in the night and you want to send it at a decent hour, you can just delay for a few hours that message. It will be invisible, it will stay invisible in the queue, become visible at your scheduled date. This is again built in to the storage queue functionality. And another thing that's built in and it's really cool is the redundancy for zone and geography. So if you have some data that's sitting in the storage account and it's needed to have in two different locations because of regulations or because of high availability flow that you want to offer to the customers in case one location fails, which might happen, you can just configure this with a few clicks, which is great for us. And the final part of the building blocks is the event grid. So services, while performing logic, will generate domain events. These get sent to Azure Event Grid, and whoever is subscribed to those events will receive via Azure Functions some triggers, and the Azure Functions will get executed. This is pretty standard uh, workflow, and it's really working for us. It's Azure Event Grid is pretty standard solution in terms of how you can configure it. It's topic based, so it's really similar to Kafka. You subscribe to these events with filters, so you can filter by event type, by event subject, by data version. You can have data versioning of the messages. You can filter by payload. You can look inside the payload and filter that so that you don't get triggers for a subscription all the time, and only in case of some of those, in the case that those filters are met. So this is a really straightforward to use product. It's scalable. Cost is very small. So for us, as of now, it's negligible, the cost of this infrastructure, this product, Event Grid. But it allowed us to instantly get started with having an event broker inside our platform and connecting all of our services together. So this was really nice product to use. Now, I'm done with part two, and I think I have 2 more minutes, unfortunately. Part three, there's no more questions, so I'll just briefly go to part three, lessons learned, just to get some ideas out there. We have a hard stop at 2:40, right? Alex, just confirm on my chat, please. So some lessons learned. So I'm hoping that in part two, I just showed some very basic building blocks, how we use them, with the purpose of getting infrastructure out of the way. This is the main purpose of part two. We want to get infrastructure out of the way, especially when you are beginning, when you're launching a software platform, you're launching a product in the market, because you have to be really fast. You have to go to market really fast. You really don't want to be inventing and reinventing infrastructure type of workflows, even though what you have might not be perfect. But the cost of spending 1 to 3 weeks to think about how you will do events, it's not worth it when you try to launch something fast. And this is why when we get these out of the box tools like Azure Event Grid, we found that first of all, they're good products, so there's not really much compromise there. And second of all, they enable us to quickly get that out of the way and focus on the next things. So this was the part two. I hope I've transmitted really fast what are the choices that we use and why we use them, and starting point perhaps to someone else going through this or starting launching a new product. Okay, on part three, a little bit about extensibility. So it's a bit about the philosophy of building a platform and a software product in a startup kind of way, fast-paced, crazy, launching features every day, and this kind of environment. So a little bit of extensibility. This graph shows that if you naively, or in this graph, I try to show that if you naively go about building software, you will eventually get to some points where it's more and more complicated to change things as time goes on. And this is something that you can avoid by using extensibility principles, by having your platform being extensible instead of modifiable. And your purpose is to have the cost of change over time stay relatively constant. And this you can obtain by using these principles. So open close principle, open for extension, close for modification, part of solid principles. This is a really important principle. You get to keep what you built in the past. You don't change as much things as you build and extend things by using the strategy pattern, by using versioning. So we actually, if you have a model, scoring model that's version 1 and business asks you for a change, you don't just go and change version 1, you just leave version 1 there and build version 2, or copy version 1, build version 2, launch it alongside with version 1. Now you have both versions working together. This is a very cheap way to modify things, and in the long term it has the result of not ending up with extremely complex code with conditions and all a lot of logic in the same place in the sort of godlike class. So this requires you to embrace a bit of duplication. We'll talk a little bit about don't repeat yourself. You know, this is a principle in solid principles, but I will simply mention that don't repeat yourself is a trap. You have to be really careful when you repeat yourself and when you don't. It is allowed to repeat yourself. We don't repeat behavior or we don't repeat ownership of a certain flow, but we do repeat code a lot. And because we avoid coupling. So some ways that coupling is created between services accidentally is code reuse, data reuse. So imagine some other service coming and accessing your services database directly. That's an anti-pattern. But this is why you might need some duplication of data to avoid this. Common SDKs, the tools assembly, common assembly, these types of packages that we are also familiar with, we try to avoid them, or we really think whether it's worth it to put a lot of code in these kinds of packages. We keep them to a minimum. Also, an interesting thing here is to look at if conditions. These will create coupling between your services. And if you go search the web for this article, this YouTube talk, it's really good one. It will show you how by using if conditions you are creating coupling between components, and it's really anti-pattern in some cases, and not all ifs are essential. Some of them are accidental. You want to avoid these accidental conditioning. They are not based on business logic. They are actually based on your design limitations and overall code, that previous code that you have written. Domain-driven design helps with cohesion. It will help you structure your ideas, the business workflows, and terminology. I'm going over to the last slide here. You need ubiquitous language. You need to align the language between the business, the testers, developers, shareholders, clients. This is an effort that if you do and if you get right, you will avoid rewrites and you will avoid pain and suffering in the future. You will avoid a lot of explaining to people what that component is or it does. So just these are some quotes from Martin Fowler. You should have a common rigorous language between developers and users. So this is what you try to use, and this will help you with naming variables, naming components, naming whatever things that you build. You solve one of the major problems in computer science. So we know that the two hard things in computer science are cache invalidation and naming things. So you can solve this problem of naming things by not naming them as an architect or software developer, simply by going and asking for the name from the domain experts. So